Very good morning, students. In the series of lecture based on the topic Basic Concept in Chemistry, after the exhaustive discussion of limiting reagent as well as concentration and the mole concept, and the last part of this chapter is laws of chemical combination. My dear students, these laws are based on atomic mass, not atomic number. First thing. Secondly, all these laws are modified from time to time. But since it is the classical part of the chemistry, that is why we have to study different laws of chemical combination. My dear students, tell me how many laws are given given for chemical combination. So there are 4 laws. First is, write down everyone. First is law of conservation of mass. Later on, it was modified in the form of energy after few years. So first law of conservation of mass, or this is called as law of indestructibility of matter. Indestructibility of matter, right? That was given by, who gave this law? At the time, and Lavoisier was the then known as father of chemistry. So it was given in 1774 and proposed by Lavoisier. Second is the law of, you see, constant composition. Law of constant composition. Or law of definite proportion. Who gave this law? French chemist Proust, given by Proust. Third one is law of multiple proportion. Who gave this law? Law of multiple proportion? Yes, given by John Dalton. And then fourth is the Gay-Lussac's law of combining volume, as this law was given by Gay-Lussac. So law of reciprocal proportion was not included nowadays. It was obsolete law. So there are 4 laws, my dear students. One is called law of conservation of mass. Later on it was modified in the form of law of conservation of mass and energy, and indestructibility of matter, proposed by the Lavoisier. Then second is the law of constant composition or law of definite proportion. Then the next one is the law of multiple proportion, and the last law is the based on the volume. So dear students, these 3 laws are based on the mass, but the last law is based on the volume, whenever gases combine together in terms of their volume. So let us discuss one by one. So my dear students, first we have to write down all these laws, and let you take one law of, first one is the law of conservation of mass. Anybody can define this law? Yes, it is very easy. This is defined as during any physical change or chemical reaction total mass of reactant is equal to the total mass of what? Products. So it is very easy to understand what is this law. Whatever the mass of the reactant must be equal to the mass of the product, whether their formation may be changed, color may be changed, whatsoever during the chemical reaction, new substances are obtained, but before the reaction and post the reaction, pre and post, whatever the mass you have taken, that must remain same. But some fractional values may be changed. It is due to the experimental error that can be omitted. See here, and during any physical change, for example, in case of the physical change, let you take very simple experiment. Let you take some pieces of crystal of ice and put it in a beaker, right now, and then you heat it gently. After some times, now ice changes into liquid. Before the reaction, before the formation of the liquid, whatever the mass we have taken of the crystal of the ice, after the formation of liquid changes into the crystal changes into the liquid, the mass obtained in the product will remain same. So it is a physical change, it is a temporary change, not a permanent change. Only the state is going to change, and the composition of water is this time H2O, and other side also the H2O. Therefore, whatever the mass we have taken before, formation of the liquid, whatever the ice taken in terms of the crystal, therefore the total mass of the reactant should be equal to the mass of the product. Ice in solid state, gently heated slowly, and then changes into what is that? Liquid. That is the water, and again it is the ice in the term of solid, in form of solid, it is also liquid. So the mass, if it is taken as the x gram, here it is also taken as the x gram. So both the masses remain same. So far as physical change is concerned, second is the, you can say, chemical change. In case of the chemical reaction, according to Landau's, a scientist who performed an experiment, he prepared a Landau's lamps. It is a very simple apparatus like this, and then this is called as Landau's lamps, this side, and here it is a kind of apparatus. Here they put silver nitrate, and this side they keep NaNO3. After the formation of the new product, AgNO3, whenever react with NaCl, right now NaCl, then the new substances are formed. What is that? It is the Landau's lamps, or you can say apparatus. So AgNO3, write the reaction, everybody. AgNO3 plus NaCl, that forms, it is the aqueous state. It is also in the aqueous state. AgCl in the solid state plus NaNO3. This is the NaNO3. So you say it is the white PPT is obtained. Now whenever silver nitrate reacts with sodium chloride to get a white precipitate of, you can see AgCl, and the side product is sodium nitrate. So my dear students, my purpose is here to prove whenever the mass of the AgNO3 plus NaCl, let it be x gram and the y gram, and when the reaction takes place in the Landau's lamps, therefore AgNO3 combined with NaCl, AgCl plus NaNO3, and then you can see whatever the product formed, that the mass will remain same. So according to this law, as the name is the conservation, to conserve to preserve the mass of the reactant as well as the product will remain same, whether it may be taken in terms of the physical change as well as in chemical reaction. But tell me, anybody, do you have any drawbacks of this law? Yes, dear students, this law is successful only in the chemical reaction but not in the nuclear reaction. Like defects of this law. Defect is the first, is we can say failed in case of nuclear what reaction. For example, always mass of the product is lesser than the mass of the reactant. Mass of the product is lesser than the mass of the reactant. This is the feature of the nuclear reaction. Where does the mass go? That is known as in physics mass defect. That is called as mass defect. I give you one example here. Uranium 92 to 35. Whenever struck by a neutron, fast moving projectile neutron, then it forms barium plus krypton. 56 and 36, 141 and 92. My dear students, see the lower part here, 92 plus 0, that is 92, 56 plus 36, that is 92. This part is here 0. So the lower side is very much balanced. Go to the upper side, atomic mass uranium is 235, but uranium is an isotope, it can have 238. Either you take 235, then 235 plus 1, 236, but here the mass is 233. 141 plus 92, 141 plus 92, that is the 233. Then where the mass has gone in terms of the neutron, to balance it, make it 3 times. 3 times neutrons are formed in addition to barium as well as krypton. So mass of the products are always lesser than the mass of the reactant, and then in addition to that, tremendous amount of energy is released. Therefore, this law has shortcomings in terms of what reaction? What reaction, dear students? It is the nuclear reaction, where it is known as mass defect. Many more reactions you can put here to prove that this has some failures here. Therefore, according to Einstein, you know Einstein's equations, that is what E is equal to, what is that? mc square. C is the velocity of light, it is constant. We will study this equation in the atomic structure, the coming chapter, and then E changes into the, if C is the constant, E changes into the mass, and mass comes back to the energy. So energy and mass are interconvertible to each other. So energy changes into mass and mass changes into energy. Therefore, this law was further modified as, it is known as law of conservation of mass as well as energy. So during any physical change or chemical reaction, sum total of, modified form of this law is the sum total of mass and what is that, energy of the universe remains what? Remains constant. Whatever mass goes to the energy, energy changes into the mass, interconvertible, but that is up to the universe. I have classified the day 1 universe as matter and radiation. Matter is of 2 types, physical matter and chemical matter. Radiations means various forms of the energies. So this is all about law of conservation of mass and energy. It's all right. Just you note down everything here. And my dear students, I will put myself, I will switch over to the next law, law of constant composition. As the name is the law of constant composition, or you can say definite proportion, whatever proposed by the Lavoisier, proposed by the Proust, French chemist. A pure chemical compound is formed by their fixed ratio of their atomic mass irrespective of their different sources. Sources may be of various types, but whenever any substance is pure, and that you remember, pure substance is known as compound. Dear students, why it is called as compound? Because of compounds are formed by the fixed ratio of their atomic mass. Fixed ratio of their atomic mass. So whenever it is a compound, mass of the substance remains constant, whether it may be obtained from the various sources. So my dear students, but the mixture is not like that. Water is a compound but not mixture. But air is a mixture but not compound, because of the ratio has not been remained constant in case of the, you can see, air, but the water is fixed by their atomic mass of their ratio. For example, a chemical compound is formed by the fixed ratio of their atomic masses irrespective of their different sources. For example, you take water from, what is that, land, you take water from pond, river, rain, whatever the source may be, various tap water, Ganges water, water from any country, from any source. The composition of water is 2:16 or simplest ratio is 1:8. So the sources are various, but the composition remains constant in terms of their atomic mass. So it is very simple law. A pure chemical compound is obtained by the fixed ratio of their atomic mass irrespective of their different sources. Secondly, you can take the formation of carbon dioxide. Anyone tell me, how can you get carbon dioxide? Anyone? So carbon dioxide can be obtained by the combustion of carbon. If I say, for case of CO2, I take it C plus O2, that is CO2. Decomposition of CaCO3, decomposition reaction, CaO solid plus carbon dioxide gas, Na2CO3 plus twice HCl, twice NaCl plus H2O plus CO2, and then decomposition of sodium bicarbonate. Dear students, sodium bicarbonate, NaHCO3, what is that product? Na2CO3 plus H2O plus CO2. Therefore, in all cases, carbon dioxide, and carbon dioxide. Tell me the ratio of the carbon and oxygen in terms of the carbon dioxide. That is 12:32, or the simplest ratio is 3:8. Sources may be combustion of the carbon, decomposition of limestone, reaction of dilute HCl with sodium carbonate, or even decomposition of sodium bicarbonate. In all cases, CO2 is obtained. Sources are various, but the ratio remains constant. That is why this law is called law of constant composition or definite proportion. But anybody tell me, do you have any drawbacks? Yes, anyone? Tell me. Yes, the defects of this law is that, first, it is applied only for pure substance, not for impure. In chemistry, if you talk about the pure and impure, impure is not any word. It is actually mixture, because mixture is considered as impure because of ratio is not constant. Pure compound means chemically they combined and the product is the compound. Water is a compound but not mixture, but air is a mixture but not compound. So in compound, the individual reactant do not carry their previous character or property, but in mixture they do carry their previous property. Whenever compounds are obtained, they lose their previous character. So water is a compound, and then it is applied only for the pure substance. Second, This law is applied. This law is failed in case of what? Failed in what? Anybody? Isotopes. What do you mean the term isotopes? Isotopes means atoms of an element having the same atomic number but different mass number. For example, if I say carbon has 12 atomic mass and this carbon has 14 atomic mass. This is called CO2 and this is also called CO2. But tell me, both are carbon, both can form carbon dioxide. But here, my dear students, what is that ratio? 12 is to 32 and 14 is to 32. What is that ratio here? Simplest ratio is 3 is to 16 or 7 is to 7 ratio 16. But ratio is not similar, but the compounds are same. The way you can say this law is failed in case of the isotopes. But at the time isotope was not discovered, so that is why it was no drawback of this law. Second, next drawback is the isomerism. Isomerism. Compounds having the same molecular formula but different structural formula with different physical and chemical properties known as isomerism. If I give you isomerism C2H6O, it has two compounds CH3, CH2 and OH. Second is CH3, oxygen and CH3. It is called as ether or it is called as alcohol. You remember in 10th class you might have done ethyl alcohol, and then second is the dimethyl ether. In IUPAC system it is ethanol, it is methoxymethane. Methyl dimethyl ether is methoxymethane or ethyl alcohol is the ethanol. My purpose is here to explore the drawback of this law. My dear students, in case of C2H6O, what is the simplest ratio? In case of C2H6O, simplest ratio is C2H6O, 12 into 2, 24, ratio 6, ratio 16. What is that simplest ratio? Simplest ratio is 12 is to 3 is to 8. Ratio remains constant, but the compounds are different. One is the ether, another is the alcohol. In the initial case, in case of the isotopes, compounds are same, but the ratios are different. But here, the ratio same, but compounds are different. So it is very, strange of this law that was failed. Is it clear to everyone? This is all about law of, constant composition. I hope that you write down. I give you the pause and then just to complete information. Yes, I will switch over myself to the next law. That is called as, third is the law of multiple proportion given by the John Dalton. As the name is the multiple proportion, that ratio is 1, 2, 3 and so on. So, see here, according to this law, when two elements, write down properly everyone, to make a note in a systematic manner, it is important for your paper. Law of multiple proportion, usually asked by the CBSE paper, that when two elements combine together to form two or more compounds, then the mass of one of the elements which combines with the fixed weight of another element where simple whole number ratio they give the simple whole number ratio. First to go through this law is that when two elements combine together to form two or more compounds, then the mass of one of the elements which combines with the fixed mass of other bear simple ratio. So is it clear to everyone? For example, if I write carbon combines with oxygen to form carbon dioxide. First of all, carbon plus oxygen, you can say, first write carbon monoxide. Carbon whenever combines with oxygen to form carbon monoxide and other carbon dioxide. Carbon and oxygen combined give two or even more than two, but in this case only two compounds. Then the mass of one of the elements, which combines with the fixed mass of another bear simple ratio. That is the 12 is the fixed mass of the carbon, 16 is the oxygen, and that is the 32, because oxygen how many times? Oxygen here 2 times. So 12 is the constant, and the ratio of 16 is to 32 is ratio is what is that? 1:2. That gives simple ratio to each other. Simple ratio to each other. So that other way you can say sulfur dioxide and sulfur trioxide. My dear friends, 32 is to 32, 32 is to 48. What is constant? 32 constant. What is that ratio? 32 by 48, that is 2:3. It is the simple ratio. I give you other example here. So first you write down carbon monoxide, carbon dioxide, sulfur dioxide, sulfur trioxide, and then you can say water, H2O and H2O2. What is that ratio? 2:16, 2:32. Hydrogen peroxide and water molecule. Hydrogen mass constant 2:2, but what is the variation in terms of the oxygen? Here the oxygen is, you can say 16/32, that means 1:2. In that way you can say, I give you the homework and you can prove that nitrogen has various nitrogen and oxygen when combined to form various compound NO, N2O, N2O3, N2O4 and N2O5. They to get the fixed mass of the nitrogen, it is the nitric oxide, it is the nitrous oxide, or you can say it is the laughing gas. It is also known as the laughing gas. Dinitrogen trioxide, dinitrogen tetroxide and dinitrogen pentoxide. You consider the mass of nitrogen remains constant, and then you take the oxygen in various form, and you will get the answer 1:2:3:4:5. You will prove it. You will prove it, the law of multiple proportion, by taking the oxides of the nitrogen. This law was also failed in case of known failure in case of stoichiometry, non-stoichiometry compound. That compound doesn't fix ratio of the atom. That the part of the atom is found to be in fraction. Non-stoichiometric compound, FeO. This is 0.98 iron is there. For that kind of compound, this law is failed. So this is called law of multiple proportion. And then last is the, you can say, Gay-Lussac's law of combining volume. As the term volume is already incorporated in this law. So what is Gay-Lussac's law? Write down the last law is the Gay-Lussac's law of combining volume. So here Gay-Lussac's law of volume under see, according to this law, under similar conditions of temperature and pressure, under similar condition of temperature and pressure, gaseous molecules combine together in terms of their volume gives or bears simple ratio to each other, because it is based on volume, because you have taken the gaseous molecule, not the mass. For example, H2 plus Cl2, that gives twice HCl gas. What is the volume here? One volume chlorine, that gives two volume. What is that ratio? 1:1:2. If I give you 2H2 plus O2, that gives 2H2O. Two volume, one volume, and this is two volume. So what is that? The ratio, right from the reactant to the products, dear students, just to see the stoichiometry in terms of their volume, 2:1:2. So answer is 2:1:2. Other example, I give you 2SO2 sulfur dioxide plus O2 to produce 2 times sulfur trioxide, 2 volume, 1 volume and 2 volume. Once again it is 2:1:2. And last is the, for example, you can say N2 gas plus 3H2 gas, that gives 2 times ammonia gas. It is the 1 volume, 3 volume. So what is the right answer? 1:3:2. So this is called as Gay-Lussac's law of combining volume. And then next is the Berzelius. All the laws are finished. All the laws of chemical combinations are over. Now, in addition to that, we'll discuss some other part in terms of Berzelius hypothesis. What is Berzelius hypothesis? Equal volume of all gases under similar conditions of temperature and pressure contains equal number of atoms. But the atom in this form is divided. But so far as John Dalton is concerned, atom is not divisible. The way this law was modified in terms of Avogadro's law. Under similar condition of temperature and pressure, equal volume of all gases contains equal number of molecules. So the way molecules can be divided but not the atom, the way Avogadro law saved the Dalton's atomic theory. So this way you can have the Berzelius hypothesis as well as Avogadro's law. There only you have to replace the term equal number of atoms. Now you have to add equal number of molecules. Now, dear students, the last part is the, you can say, Dalton's atomic theory. It is very beginning of the chemistry, and most of you must probably be knowing what is Dalton's atomic theory. Dalton was simply a high school teacher, and he used to explain the atom in that way. Every matter, postulates, these are called, postulates. Postulates, what is that? Matter is made up of extremely small particle called what? Atom. Atom is made by two words, a plus tome, not cut, not divisible. It is a Greek word. So according to Dalton, that atom is such a substance, इससे छोटा दुनिया में कुछ नहीं होता. इसका मतलब that is atom is the extremely small particle of an matter. Then second postulates, atom is what? Atom is invisible, indivisible, and indestructible. Third is the atom is neither visible, not divisible, and not destructible. These are, invisible, indivisible, and indestructible. Atom of the same elements are similar in all respects. What is that? Shape, size, color, etc. It is the opinion of the John Dalton. Today it is not correct, but it is the classical concept or postulate. That is why postulates is not verified. So here, atoms of the same elements are similar, but further I write, atoms of the different elements are different in all respects. Fifth, atom whenever combined together to give what atom? Compound atom. Dalton did not have the idea about the compound is different from the atom. Molecule is different from the atom. So, these are the postulates. Matter is made up of extremely small particle called atom. Atom is not divisible. Then atom what? Invisible, indivisible, and indestructible. But atom of the same elements are similar in all respect. Atom of the different elements are different in all respect. Atom whenever combined together to give compound atom. That is what? Whenever combined together to give compound atom in their fixed ratio, in their they bear in their simple ratio, in their simple ratio of the atoms of the various elements. Then next is the sixth is the, you can say, atom. Matter can neither be created, atom can neither be created nor destroyed during any physical change or what reaction? Chemical reaction. So my dear students, you can just analyze yourself how far the credentialities of these postulates in today's scenario. these postulates, according to modern atomic theory, was found to be incorrect. It was amended or modified. First of all, matter is made up of extremely small particle called atom. But today, according to modern theory, atom contains electrons, protons and neutrons and so many more other subatomic particles. These are million times smaller than the atom. The first postulate is incorrect. Why? Because of according to Dalton, atom was the smallest. But in today's scenario, according to modern atomic theory, that is given by the J.J. Thomson, Rutherford and then Niels Bohr, that electrons, protons and neutrons are million times smaller than the atom. Second, atoms of the same elements are similar, but my dear students, in case of the isotopes, atoms of the same elements are not similar. For example, carbon 12 and carbon 14. They are not similar. They differ in their atomic mass. So their property is going to change. Atoms of the different elements are different, but here, in case of the isobar, argon and potassium, this is the 40, you can say 39 point something, you can say here, argon and potassium 40 and 40, you can say. So they have the same atomic mass, so but the atoms are different, right? So and the next drawback was the atoms whenever combined together to give compound atom in their simple ratio. Few compounds like glucose C6H12O6, it gives the simple ratio 1:2:1, but glucose gives. But so far as sucrose is concerned, this is the C12H22O11, does not give the simple ratio. It is the big ratio, 12:22:11. So it is not fit in all cases. And then whenever atoms can neither be created nor be destroyed, but we have seen in case of the nuclear reaction, atoms are very, uranium changes into, you can see, barium as well as krypton, and the new particles are obtained in terms of the neutron, because of neutron has 0 charge and mass is 1. Therefore, in terms of the nuclear reaction, so the way, Dalton's atomic theory was modified according to modern atomic theory. I hope this is all about this chapter, just to go through the various laws of chemical combination, and then you see after that Gay-Lussac's law of combining volumes. Then you go for Berzelius hypothesis, Avogadro's hypothesis, and as far as Dalton's atomic theory is concerned, these postulates nowadays not relevant, and according to modern atomic theory, this postulate was very much improved and verified. Thank you very much. Have a nice day. All the best. God bless you.